So to kind of set up for the next team, we did implement a transition phase where we really went through and made sure that all of our comments were taken care of. I know we all comment perfectly, but we made sure it was in place so the future team could figure it out. Our sponsor was able to get a second team for a senior project to pick this up in the future. So we want to make sure the project plan, the technical report, everything was as documented as possible. We covered things we think we missed, things that we definitely want to change in the near future, things like that. And our test suite and test plan is pretty rigorous as well.
Okay, so I'm going to have to go through this pretty quickly because there's a lot of features and only a little bit of time, so forgive me for rushing through the demo. But what I want to show you is some of the features that we've been talking about on this actual website. So what you can see here is actually the landing page for where people land when they first encounter this website. If you're an anonymous donor, you see some information that tells you reasons why you might want to sign up for this page, and you see this kind of colorful bar here, a nice image. All of those can be changed, but this colorful bar represents the amount of donations that each of these nonprofits have received in their themes. So what's displayed below are some different themes like clean water, pets, activists, workers. All of those are competing right now to try to win kind of like a majority of the donations, and they might get a bonus to how much they actually win, and that incentivizes users to donate to them more. So what I'm going to walk you through now is kind of donating to one of these themes and showing you how to register for this website and sharing to social media, etc. So let's say I wanted to donate to a theme and see this bar change, see the competition actually change as it goes along. So if I wanted to donate to workers, here's the workers page. There's an about, a big prominent donate button here to make sure that people see that it's the most important thing here. And a description. This is just test information in here. And we wanted this to actually look kind of like what it might actually look like, so we populated it with actual nonprofits and actual nonprofit information. So here's some nonprofit cards down below to show you the nonprofits that belong to this theme. So I'm going to donate to workers, and what that means is this donation is going to be spread across those nonprofits that belong to it. So my donation here, I'm just going to put myself in, and my phone number is 1 through 0. I'm going to use this nice test credit card here, and I'm going to donate $75 because I'm feeling pretty generous, and I'm going to submit that. So now it says, oh, this has succeeded. I'm anonymous, so I can register to gain gold. So there's 7,500 gold on the line right now. So okay, I'll sign up. And here's the sign up page. It says, hey, I still have 7,500 gold waiting. We want to make sure they know that they should register to get this bonus. I'm going to actually sign up with Facebook because that's easier. I don't want to actually create an account, so I'm going to click there to sign up with Facebook. I'm logged in on this computer already. If I hadn't been logged in, this would redirect to a Facebook login page. So I'm just going to pick a username. This way, if I ever disconnect Facebook from this account, I can log in later with this username and password. So my really original username is going to be Ian. And I'm going to put a test password in here. Very secure. And so here's my account. That's all I needed to do to create an account. We wanted to minimize the amount of clicks because it's generally better to keep people engaged like that. So here's my gold reward. I already have 7,500 gold. In the future, what is planned for this gold that you'd be able to do, as said before, is use that to actually donate to nonprofits. So it's kind of incentivizing you to donate here because you kind of get free money out of it. And so here's my account information. It's all blank right now because I didn't put anything in. What I'm actually going to do here now is go back to the competition that I showed before and show how this changed the bar at the top there. So now Workers is winning completely because they have one donation and no one else has any donations because we didn't donate to them. So right now, if the competition were to end, Workers would get some sort of bonus or benefit for receiving the most donations. So the next thing that I want to show you is the nonprofit list. This is the list of nonprofits. They're all searchable. It's paginated at different levels of pagination. So if I say want to search for any nonprofits that have the word human in them, I could search for that, and it shows 2 nonprofits. And they're nice, neat little cards, easy to see, easy to use. But let's say I want to go to the Human Rights Campaign. Here's a page for a Human Rights Campaign. We have some randomized text here. So there's information on the representative, information on the phone numbers, the themes that this nonprofit can belong to, and another donate button with their websites actually set up. So if I click Facebook, it brings me right to the Human Rights Campaign Facebook page. We wanted to make sure that that social integration worked. Also, on the side here, as mentioned before, these links actually allow us to share whatever page we're currently on to Facebook, Twitter, or Google+. I'm not actually going to share those because this is an NDA protected website and I don't want to share it to my real Facebook account, but if I did click post to Facebook, I'd have a link directly back to this web page. A couple of the last things that I wanted to show while I'm here is just showing the process of administering a nonprofit as a representative, because it's important to the nonprofits to get information out of the users and out of the donations that they have coming to them. So I'm just going to quickly donate $75 to this nonprofit so it shows up in their list. And it shows that I have a donation now, I have a whole bunch of gold. So as an admin, I'm going to go in here and just add myself real quick as a representative to this nonprofit. And if I want to go back to the Human Rights Campaign and show that the representative that I want is Ian, that's all I have to do as an administrator. Now the Ian user can administer that website all by themselves without my intervention as an administrator. So I'm going to log back in very briefly as Ian. And here I am, and Human Rights Campaign shows up as my nonprofit here. It also shows up in my nonprofit as a card down at the bottom. A couple other things show up once you're a representative for a nonprofit. You have the edit button here, so you can edit the information on the page. Say I want to change it to my phone number. And I can do that, and I can click save and it updates the information. I can also view the report with my donation. If I click download CSV, that actually downloads a CSV of this table that we see right here. Those are all the donations that have been received by this nonprofit. Again, that's a tool, that's something that's useful for nonprofits. They generally want that kind of information. So that's all I'm going to be showing today.
So lastly, I just kind of want to go over our reflection. We kept it pretty short on the slides. We wanted to focus on our demo, but these are just kind of the big points that we noticed immediately, especially with process and how the summer went and stuff like that. So immediately the communication was a huge factor over the summer. Everything kind of sloped off. Inter-team communication, communication with sponsors, coaches, everything kind of slowed down. And not only did that hurt in terms of like getting answers quickly if we needed them, but also just our motivation kind of sloped off because of that. Additionally, the formality of everything had kind of sloped off, which both of those affected our motivation to get lots of work and things like that. As I mentioned earlier, the total planning that we did in the beginning definitely slowed us down overall. We didn't realize that we would be planning out so much not to actually build all of it, but that did affect us quite a bit. And finally, our metrics, which we didn't really cover them in the slides because of this, but they weren't very appropriate or useful for us. We updated them weekly, made sure to stay on top of everything, but we never looked back at the metrics to say like, hey, this is too low and we should do something about it, because we didn't feel that the metrics were actually that important. We definitely should have chosen more useful metrics. We really had like number of tasks, number of bugs, code complexity, which is kind of useful, but there wasn't too much we could do about it, and test coverage, which we did do something about, but that was really it for our metrics. With that, do you guys have any questions for us? Zane?
Why did you choose, or why was it required to choose $5 as the minimum amount?
Especially with like PCI, or what is it, PayPal and Stripe both have like surcharges and things like that, so it's, I think, 30 cents plus 3% or something. So just to kind of minimize that and increase the general user to donate a little bit more, we wanted to set a minimum so people weren't donating 10 cents and then we end up covering the rest of it.
But also, you kind of want to push users towards higher donations, and higher donation for someone who might be in the young adult category might actually be like $5 sometimes. So we wanted to pick something that was easy and bite-sized, but also substantial in some form.
Now, I know you mentioned that some of your features using the goal aspect of the application didn't have a chance to implement. But my question is, you said that you could donate to goal. Where does that money come from?
So basically what happens is this website, you have nonprofits sign up for the website and then they kind of pay like a maintenance fee. They pay a sign-up fee and then they pay recurring fees per month to actually be a part of this website. What they're getting in return for that is they're getting increased user flow to them and increased awareness of their brand and who they are. So they're getting increased contact with young adults. That's kind of what they're paying for, but that fee actually covers the young adults getting the bonus donation. So that's kind of on the back end, on our end, the social philanthropist covers those extra little bits, and it's definitely not like if you donate $50, you're not going to get like $50 back. It's going to be like $1 or something like that, something more sustainable, and that can be altered in the future. But it's covered by those maintenance costs.
The scope was a big issue up front. How did you manage to negotiate the scope, especially in the summer? How did you maintain that scope?
Yeah, so we actually, I would say maybe week 10 of spring, we had already talked to the sponsor, Patrick, and just kind of said, hey, we're not getting all this done. We planned out everything and there's no way we're hitting all this. He actually requested we kept everything in scope, whether we would complete it or not, just for motivation purposes pretty much. At about the very beginning of the summer is when he had started talking to the department about getting a future team, which will be taking it on next year. And at that point is really when we started nailing down what features specifically would we be getting to, and we started taking things in our project plan and just moving them as we saw fit. Really, it was every single time we met, we were just addressing, hey, I don't think this will get done. We kind of discussed what minimum we could do for that feature, or if we wanted to hit it at all, things like that. And we just kind of tried to update it as much as we could. Really, it was a very variable scope, and our sponsor was very happy with that, so we just left it as variable as possible.
So you mentioned that you did too much planning. Do you see that as being a positive thing for the future team that takes on the project?
I'm kind of mixed on that. I don't know how the rest of the team feels. I think that although it was good for us to have a very strong, definite plan, the next team may see all of it and think, what were these people thinking? This is nuts. And at that point, it was all wasted. So really, it depends what the next team feels about what we did.
So just to kind of clarify, we have a full test plan written with tests that can be done for users that we never get to implement because this is NDA protected, so it's hard to do user testing and acceptance testing in that within this kind of time frame. We have a full project plan. We have a full analysis of certain UI elements of the website and kind of breakdown of like user flows, types of users, that kind of thing. And those items were important, but they're important more towards the overall idea of the project rather than getting the project started up. So when we said we did too much planning, we didn't treat this website as kind of a more agile development that we needed to get prototypes running and being built. So there was a lot of churn at the beginning before we actually had a first implementation where we should have been focusing on here's one thing that works, here's another thing that works, and now we have the documentation to say why they work and what we want.
Okay, it's time for team.
What about you guys? Yeah? Hey, technical issue solved. All right, cool. So my name is Daniel Fehrenbach.
I'm Mike Shug.
David Kesslock.
I'm Kelly Trainer.
And we are Team Cyber Secure IoT. And we worked on a secure data pathway for Bluetooth Low Energy or Bluetooth Smart. We're going to go over our problem statement, the requirements and deliverables for the whole project that relate to that problem statement, the system architecture and security decisions that we made as a result of the requirements, a demonstration of the security within BLE, our test results and performance findings, the toughest technical problems that we had within our group, our progress on our documentation and research paper, and finally, future work that could be done in the project.
So in recent years, the medical IoT wearable devices are rapidly growing, and the trend is benefiting from macro power wearable sensors, efficient communication protocols such as BLE, and the ubiquitous smartphones. So the power efficiency of those communication protocols usually comes at the cost of data throughput and frequency, which are two important attributes for existing method to ensure data privacy and security. So achieving both is a significant challenge for medical wearable devices. And FDA and Department of Health and Human Services have regulations against all the nodes that are involved in the data transmission path for medical devices. So there are some existing architectures in hope to solve the data security concern for these medical devices, namely BSN Care Plus and USM IoT, but they lack the authentication security due to the encryption method and the lack of session key transfer. These vulnerabilities leave openings for man-in-the-middle attacks, location spoofing, and so on. With the understanding of the problem, we try to come up with the requirements to come up with a new solution. So, working with the sponsor, we decided to first come up with the architecture for secure data transmission for a BLE wearable devices. And with the proposed architecture, we like to implement a prototype system to validate the security performance of the architecture. And we use some man-in-the-middle attacks and replay attack and other common BLE vulnerabilities to test for those security performance. And the other major deliverable is to have a paper documenting our proposed architecture, the research we've done for the existing solutions, and our prototype. And that will be handed off for publication in the future. So I hand it to Mike for
So to sort of explain how our system is laid out, we kind of have three main portions, which are in bold on the screen. The patient device, which is a Bluetooth low energy peripheral. It contains a gyro sensor. It's going to be tracking a patient's motion. We have the therapist device, which is an Android application that's collecting data, logging it, detecting any patterns that might mean the patient is hurt or something. And the data going to that is what we're trying to secure. The electronic health record is the endpoint for this data. It would be offloaded from the therapist device to the record, but that's been out of scope for our prototype. Mainly, we are trying to protect the two types of transmissions from the patient's device to the therapist device. The primary one is the advertisement data on top, which Bluetooth Low Energy works based on service and characteristics, which, depending on how they're set up, could lead to data exposure. And then the secondary arrow there is the actual sensor data. So that's the physical motion and those values need to be encrypted in some fashion that a man in the middle can't read it. So leading into that is sort of what we did to make this architecture. The BLE chips on each of the devices are kind of focused on the lower level of the transmissions, and what we are implementing is focusing on the higher level of communication. Essentially, we're pre-encrypting traffic such that when it goes out to the therapist device, it's secure enough that we can use it for over-the-air transmissions. To do this, we kind of have two factors in here. Advanced encryption standard is our mode of encryption. We're using that to disguise all the transmissions and secure the patient data. That's running under a Galois counter mode of operation, which gives us an authenticated data stream. Essentially, one of the characteristics is continuously making tags that go along with the data. It ensures that the sender is correct, and it also ensures that previous transmissions can't be reused. In order to encrypt it between the two devices, we need to share a key on each of them. So we are performing a key transfer with an elliptic curve algorithm. The main reason for that is the peripheral is not strong enough to connect to the internet and use something like SSL to perform the key transfer. And since the characteristics are very small compared to the size of the keys, we created a buffer system to handle that. In addition, each time the architecture is loaded, a unique device credential is used as sort of an authenticator, which is based on the MAC address of the devices plus some timing data that we're pulling in. And then for each encryption, an initialization vector is stored on the therapist device, and that gets updated for every packet. Essentially, it prevents a previous tag from working on a previous message. And then to sort of test the application, we have the therapist device running Android 5 application. The patient's device, which is in Arduino 101, we chose that because it has a BLE chip provided as well as the gyro sensor. And then we're testing out the architecture using an attack tool called Getacker, which uses the same libraries as the Android application. And I think it's a good point to move into the demo.
Sure. So for our first demo, we'll be using a slightly less secure version of AES without GCM, and Danny will narrate that for you.
Cool. So yeah, just this first demo is just designed to give a simple background on some of the most basic attacks that we can run on a less secure version of the prototype, like it's at AES. Okay, let's get started. Okay, to begin with, these are our three devices. The central device and an Android phone running our custom BLE application. Peripheral device, an Arduino 101 also running a custom BLE application. And our man in the middle, a Linux PC with an additional Bluetooth dongle running our Mimic and attack suite. To show the central and peripheral in working order, the two devices are turned on and paired with one another. The application here now responds and updates its graph with data when the peripheral is moved around. Next, to show the establishment of a man in the middle, our devices must disconnect from one another simply because a peripheral can only connect to one central device at a time. We just turn off the central application and restart the peripheral device. Then with the attack suite, we view all of the devices in the area and check for any information that we feel might be security critical. This is what's called passive listening on the screen now. Then what we want to do is we want to connect to the original peripheral. We want to mimic the device and sit ready for the central device to connect to us. Keep in mind the central can't connect to the original peripheral any longer, at least not directly, because the man in the middle is connected to it instead. Here we're connecting the phone to what it thinks is the original peripheral. Instead, it's connected to us. As a request for information from the peripheral, we can view and save any and all kind of the information coming across. This is what's called active listening. Note that the information coming through doesn't look like much, but that's just because it was all encrypted. Luckily, we have the keys and sufficient knowledge of the system to decrypt all this information in real time and save it to another file. In fact, here is the file from a previous test opened up and wrapped. The encrypted data is shown in the first column, and the decrypted data is on the right in green. Not that you can see it. But anyway, in the same way that we've decrypted and saved this data, the data can be modified in any way that we wish, and either then passed through or even stopped entirely. This is called data manipulation and injection, or in the case of stopping the information, just a form of denial of service. That's the end of this demo that, again, just went over some of the attack basics on a less secure version of our prototype. Our fully secured version is protected against the data manipulation attack shown at the end, as well as replay attacks, which are essentially just more advanced data manipulation attacks that use previously sent and accepted packets. We're protected against all this because we're using an enhanced encryption algorithm, AES GCM, like Mike described a couple slides ago, that has the ability to leverage time-sensitive tagging, which directly counters all of it. That said, regardless of these protections, we know of only two, vulnerabilities that still exist within our prototype system. The first being denial of service attacks, and the second being an attack against the key transfer, which we're going to show in our following demo. So go ahead and start the video. We have everything set up just like in the previous demo. The man in the middle is ready to go, is already connected to the peripheral, and is lying in wait for the central device to connect. The difference here is that the central and peripheral devices have yet to connect for the first time and haven't performed the key transfer process. This is what the man in the middle wants. We connect the central device and request for the key transfer to begin. We can see the passing information within our man in the middle here. Not only have we modified some parts of the keys using data manipulation, so the communication between the devices was no longer possible, but we've thrown in an Easter egg displayed on the phone. Apologies, you have most definitely been hacked. Sincerely, the hacker. Since we have full knowledge of the system, yes, we could have simply used the keys that we stored, but a denial of service attack like this is a little easier, especially because of the complexity of AES GCM. In case it was not clear, the devices could no longer communicate with one another. The peripheral could send information to the central, but the central could no longer interpret the information and then could no longer graph it. It's like they were then communicating on two different wavelengths. The system, at this point, could no longer work until the key transfer process was redone without modification this time. And that's the end of the second demo. That again just demonstrated one of the only vulnerabilities that we know, maybe two, if we count the denial of service. And while it does appear frightening, there's a large set of preconditions that need to be met, including advanced knowledge of the system and, almost more importantly, catching the peripheral, copying it, setting the man in the middle up to record and or change information coming through, mimicking the peripheral, connecting to the peripheral, all before the central connects to it for the very first time. Even in a controlled environment, we had a hard time setting up this demo, and it would be many, many times more difficult to do so within a dynamic environment, especially without any prior knowledge of the system. Once you miss the key transfer, the system's data is secure and can't be unencrypted without using half the world's power to do so. That said, there's still some forms of denial of service that then can create some inconveniences and annoyances regardless of the system's data protections, simply as a result of Bluetooth's low energy's merits. Those being constant advertising of the peripherals and the restrictions and processes of the central and peripherals connecting to one another. In fact, the denial of service can be performed even without any knowledge of our system. We talk more about the protections against denial of service in our future work section.
Okay. So to evaluate the performance of our security, we created this chart to sort of illustrate the different types of security that are available for BLE. The first two columns illustrate two pairing methods that are native to the BLE spec, JustWorks and passkey entry. These, as you can see, fail most of the exploits against BLE, and so they're not suitable for secure data transmission. As Danny mentioned, denial of service is unavoidable. We can't prevent that through encryption alone, due to the nature of BLE being
a radio transmission. Passive listening is easily mitigated by simply not sharing any sensitive data on an insecure channel. AES has one shortcoming with respect to AES GCM, in which data manipulation and data replay attacks are possible, whereas with GCM they are not due to the added authentication and timing security. There is one caveat with our active listening tests in that our key exchanges do occur on an insecure channel and therefore are susceptible to active listening, but all subsequent transmissions are secure.
And now what's on the projector is just a chart displaying our performance findings and some of the some of the solutions that we explored. There's two main takeaways. The first is that the number of packets that we can transfer over the data path using GCM is significantly slower than not encrypting it at all. In fact, about 31 times slower. You only get about 3% of the output. Despite how slow it is, about 750 packets per second, our sponsor is okay with this, and so are we, because he only asked for about 100. Second takeaway from this is that there's a lengthy key exchange that needs to happen, but we're okay with this. It's about 11 seconds long. We're okay with it because it only needs to happen the first time or whenever you need to refresh the keys, which is hopefully only like every few months.
And to go over some of the technical problems, the main thing that we encountered was synchronizing the data transfer, essentially message tags coming out of order with the messages. And essentially we have a set of flags to set which message belongs with which tag, and then in addition, for the key transfer, a different set of flags for essentially this is the correct packet, and ensure that everything is received in the right order, because otherwise the key transfer doesn't work. As far as the memory and time constraints, we had to choose a library that was small enough to fit on the board, but fast enough to be useful. In this case, the AES algorithm can be a lot faster, but you need a lot more space to pull it off.
Some additional challenges that we faced when developing the prototype included idiosyncrasies between the different platforms and the respective libraries that were available on each. For example, the Bluetooth stacks and crypto libraries had slightly different implementations. Additionally, these libraries had very scarce amounts of documentation, which made troubleshooting very difficult and resulted in a lot of trial and error troubleshooting.
This project involved a lot of documentation, and outside of our regular software engineering deliverables, our team was tasked with writing a research paper on Bluetooth Low Energy in the context of medical applications. The paper goes into detail how our team researched current security architectures and designed one specifically for a mobile medical context. It involved researching common attack patterns against BLE systems, and goes into detail how our security architecture handles those attacks. The paper was written in IEEE format and will be submitted by our sponsor for publication. Future work for this project would involve fully developing a user interface for both the central and peripheral devices. By storing shared keys on both central and peripheral devices, the time that it takes for the system to do a key transfer decreases, as well as the frequency. This would make using the system easier and marginally more secure. Power optimization on the peripheral device could extend the overall system's battery life and make the usability of the product more, it could increase the usability of the product. The system could also benefit from a more in-depth look into out-of-band key transfer as an alternative key transfer method that is more secure. As far as further testing, the system is still susceptible to denial of service attacks and could be vulnerable to other unforeseen attack methods.
And that concludes our presentation, guys. We went through our domain requirements, architecture, security decisions, a demo, technical problems, our research paper, and considerations for future work. Thank you very much. Give yourself a pat on the back for following along. Are there any questions? Went forward the field, huh?
Anything at all?
Anything? No? We have so much to talk about. We did an entire research paper on it.
I think you mentioned at the end there, but considering the only downfall of the AES and the AES GCN or whatever is that if the man in the middle is there for the first communication, they can still actively listen to the devices. I think you mentioned it, but is there an idea of just requiring that you connect the two devices by some sort of wired communication that can't be
Yes. This is actually an idea that came up week 2 of the spring semester. Essentially, the only way to do a secure key transfer would be something that isn't BLE, because BLE has been proven to be fairly insecure. The reason that we didn't explore it for now is essentially a project requirement. The idea would have been that the usability is low because now the therapist has to wire the two devices together every time they want to load the applications. And we were trying to think of some possible way to avoid that. Really, it's unavoidable, but the future research would involve not so much how to do an out-of-band key transfer as for how to sell an out-of-band key transfer in a way that is suitable for the end user.
And to mention that it's incredibly difficult to get in on our first communication anyway. Some of the users that make the devices hide the names, and you might see a list of 50 in a room of people just this size.
What can be done about denial of service attacks?
You could not use a wireless protocol.
Because I know there are some, like, basically what some cloud solutions implement is pretty basic even today, which is just looking at how many packets are getting from one source within a particular period of time, which wouldn't work with this because you need all of your packets to come from one source and you need a lot of them very fast. So is there anything that you could do about?
We haven't come up with anything yet. The biggest impact of it all is you could use a denial of service attack to socially engineer somebody to reset the keys.
Right.
So
The idea in Bluetooth Low Energy is that one device can connect to one device, and once the man in the middle is there, you're only connecting to the man in the middle because it's there. There may be some future improvements, like Bluetooth 5, I believe. First off, they're improving the encryption method by default to the one that we suggested in the paper, which should help to mitigate against the man in the middle in the first place. I believe they might also be doing something with the channel switching to help the peripheral devices connect to the correct source.
All right, let's thank the team.
All right, we're Team Avalanche, and our project is called Recruiter. I'm John.
I'm Max. I'm David.
I'm Zane.
And we've got our sponsor, Jim Bondi, with the Office of Career Services, who's not here today, and Timothy Witcher is our coach. So we're going to be going over a bit about the context of our problem and what it solves. We're also going to be talking about our customers' needs and requirements, and to give you guys a little demonstration, and then talk about the challenges and future work related to the project. So our project actually originated with our sponsor going to a conference. They were talking about how they could modernize the setup of job applications and how students would be more influenced to set up or apply to jobs and how they'd be more satisfied with the process. They ended up coming up with a pitch that our project was based off of moving into the spring semester. They wanted to create a faster and more reliable way for students to apply to jobs, and they wanted employers to not have to sift through hundreds of resumes, and that's the only thing they got from the student. We decided to move into a mobile application, kind of, our project was originally called Tinder Meets Career Services, so we wanted to be able to have an easy way to match, but also a longer period in which you could build up the match and determine that the student was correct for the job and the job was correct for the student. We create the initial match based off of a set of skills made in the job posting and a set of skills that the student associates with themselves. And after that, we move into a set of phases where the student gets to build up their job application and also see more information about the job that allows them to determine that the job is right for them.
So going through the project, there were some requirements that we had to meet, and first of which was user registration. So we needed to have 2 users have the ability to register within the app. We have the recruiter and the student, which we'll go over in the demo. Then job posting creation. We had to be able to add skills that were associated with that job posting and all other job posting information you might find in any other application. Then we had to create a matching algorithm which would match students with job postings based on their skills. And what makes our app different from other recruiting apps is the phases that the students and recruiters both have to go through. So we have 3 phases. The problem phase, which the recruiter kind of puts out a problem statement where the student has to respond to that problem the best way they can. And then we have our presentation phase where the recruiter wants to sell their company to the student and the student wants to sell themselves to the recruiter. Then the final phase, which is the interview phase, we also call this the reward phase, which you'll see later on in the demo. And then the app must be able to accept and deny at any point, so students can decide that they're interested or not interested at any point in the application. Same goes with recruiters. They could no longer be interested in students. If they so choose to, they can decline them. And then part of the app is we wanted to display contact information for both the recruiter and student, so that way they could contact each other to set up interviews, which is, again, the end goal of the application. So we'll go into our demo quickly. So on the left side, we have the student, and then on the right side, we'll do the employer. Again, these are iOS and Android devices. So as you can see, the left side, the student registration has fields that you might expect: first name, last name. The email, the student must sign up with their school email. They enter their school name, graduation date. Optionally, they can enter their phone number. Some other preferences they could enter are job work location. So depending on they want to work in New York. Another one is company size. We have startups. These are just categories to kind of put for each company, what kind of company they want to work for. And then on the right side, you have the recruiter registration, which is almost the same field, but something to note here is that they must register with their company email. Now, if the company email is not correct, and it's not in our database, they must register that company. prompts them to register their company, and it's brought into another form to register that company. So if a recruiter registers that company, they're not automatically accepted. They have to wait for the administrator to accept that company. This mitigates people trolling the application and making up fake recruiters and fake job postings. So they have to be accepted by the administrator. But we're not going to bore you guys with some of the registration. We already have students and recruiters in our database. We're going to sign in with them. Again, on the left side is the student, and on the right side will be the recruiter.
So as you first log into the app, you get shown a list of your current matches. These are job postings that the student has already been matched with based on their skills and the skills of the previously created job posting. We're going to go into the student's profile right now. You can edit it whenever you want. But we also want to show the resume upload, because a lot of people update their resume pretty often. You just go to your resume that you have on your phone, upload it, and then that will be viewable by the recruiter as they get into the later stages of the application process. And then we can go into our skills matching. This student already has a list of associated skills that they put in previously. These are just things that the student thinks they're skilled with, and they're based off of a list in our database right now. We have a preset set of skills that we got and preloaded, but you can add a new one if you learn how to do something via a tutorial, but you can also delete old ones in case you've gotten a bit rusty and you feel you would no longer like a job requiring those skills. So as a recruiter, we're going to go and create show a new job posting creation. You've got the position name and the description, which is normal with job postings. And another normal feature of job postings is that they have a list of skills that you need, like presentation skills or communication skills. But they also have a list of nice-to-have skills, but they aren't necessarily required. Like some job postings would want somebody to have experience in Java, but they're not going to take somebody. They're not going to refuse somebody who has a lot of work in C#. But based off of those skills, we generate a match to the student skills by generating a number based on the percentage of the required skills they have and the percentage of the nice-to-have skills they have. The importance of the nice-to-have skills are determined by the slider at the top. So that weights them differently as we're generating that final number to determine whether they have a match. And the threshold is how strict we require that match to be. So like if you put it as a stricter threshold, they'll require a higher percentage of the skills to show up as a match on the student screen over there. And then we've also got the phase timeout, which decides how long a student has to respond to move through a phase, and how long the employer also has to respond. So if the student decides they're interested in a job and the phase timeout is 1 day, the student has 1 day after entering the presentation phase to post their presentation and accept the employer's presentation, and then the employer has 1 day to respond back. So we're going to go into our first phase. You show interest and then move on to the student immediately moves on to the problem phase, where they're shown the problem that the employer put in as they first created the job posting. Right here it's related to the job, and it's comparing various web frameworks. The student is supposed to accept that problem is something that they would like to work on, and say that their response to the problem in order to show the employer that they know how to work with that kind of thing. And on the employer's side, they look at the response to the problem statement, and they're able to decline if they don't like the response, or they can tag it and save it for later in case they want to bring it up with another person, or they can accept it and move that student on to the presentation phase.
In the presentation phase, the student can view a presentation about the company they're applying to, and the recruiter can view a presentation about the student. Here we have the student looking at a Jeff Brad Smith talking about how important small businesses are. They view that if they wish. If they like the presentation, they can input a link to their presentation and accept this phase. If they don't like it, however, they can say they're not interested anymore, and they move out of the matching or that job posting, don't match with it again. So to go back to this job posting page, you see there's we're looking at the web architect page, web architect job, a different job. The point is that there was a little new icon to show you there was new matches. Here you can see there's like one new in the presentation phase. This is a separate job posting. So here the recruiter can view the student's presentation. This student built a jet suit, which is pretty cool. So you can then accept that student's presentation. And the student moves on to the interview phase. In the interview phase, the student can see lots of information about job posting. The position title, description, the company location, and the recruiter's contact information. They then email or call the recruiter to schedule an interview. The recruiter can see equivalent details in the interview phase. They see the student's name, their school, graduation date. They also download the student's resume to familiarize themselves with the student before the interview. They can then email the student to schedule the interview, or if for whatever reason they don't like the student anymore, they can decline, and the student is again moved out of that matching for that job. Going back to the presentation. We ran into a few challenges as we made this app. The first and possibly biggest was during the requirements gathering phase. Our app, similar to the app of the social philanthropist team, wasn't really well defined initially. We had to spend a lot of time talking to the sponsor to negotiate requirements and figure out what exactly we were building. So I didn't start really working on code until after spring break. Once we started working on the code, we had some more challenges. A couple team members had problems setting up their development environments, which took a few weeks out of production time. We also had a false start when we were making the client-side apps. We used Xamarin, so we could build one code base for iOS and Android. We initially wrote our UIs using the Xamarin native UI libraries that are one code base for iOS, one for Android. The Android one was fine, but the iOS code base was very hard to work with, very poorly documented, just total pain. So we switched to Xamarin Forms, which lets you write one code base for both iOS and Android. It took us 4 days of working Xamarin Forms to do what had taken 2 weeks of working the iOS library. We've stuck with Forms ever since. Forms isn't perfect though. We had to do a couple platform-specific features related to file upload and download. There's no cross-platform way in Xamarin to handle those things. We also had some trouble with sizing and layout, getting everything to look fine. You saw that the apps look different on iOS and Android. It's actually the result of a lot of work to make them look similar, at least. We also had, finally the challenge was team members going out of town for job interviews and other such things. We had to schedule work around everyone's busy schedule.
Alright, so we talked about what we did, now let's talk about the future. So to begin, we feel that with the prototype we've already developed, we have a very solid base and foundation for any future teams to continue work on this application. And even toward the end of our development, we found that our feature additions became simple expansions on what was already there. But that being said, there are some things that we didn't have time or didn't have the chance to implement. These things we decided were low priority, mostly quality of life features that we agreed with the sponsor weren't critical toward the mission of the prototype, which was to create something that can demonstrate that innovative application process that you saw a little bit ago. So the first thing was push and email notifications. Originally, it was meant that users would be able to configure when they wanted to receive push and email notifications for events such as acceptance or declination during the different phases of the application. In addition, the interview or reward phase earlier was intended to be a scheduling feature. It was intended that recruiters would be able to fill out a calendar of when they had available times to meet with students, and then students could view those times and select from those times when they'd like to interview with the recruiter. Then there was one feature that we actually had trouble implementing due to a technical constraint provided by Apple. We had insufficient permissions for accessing various parts of the iOS file system on iOS platforms, and therefore couldn't get file upload for student resumes working on that platform. Next up is the administrator website. Zane mentioned earlier that when a recruiter registers a new company, that company requires approval by an administrator of the system before that recruiter can proceed further with the application. This task, along with others such as gathering analytics about application usage, were intended to be done through an administrator website that ended up not being feasible during our time constraints. These features, along with simple sorting and filtering throughout the application, were agreed upon with the sponsor as lower priority, as again, they weren't critical to the prototype in terms of what it was really meant to do, which was demonstrate that innovative application process. In addition to these features, there were conversations throughout the development process of features that could be handy if they were added in the future. The first one of which is third-party service integration. So third-party service integration with applications such as Facebook or LinkedIn could be very helpful during the registration process to pre-fill a lot of those fields so that users didn't have to type them all in, which can be strenuous considering that it's a mobile application. Next up is recommendations. So there was discussion about potentially allowing recruiters to recommend students that had originally applied to one job posting but weren't the best fit, but perhaps were a better fit for another job posting. Recruiters could recommend those students and speed up the matching and application process with that new job posting that they think they're a better fit for. Lastly, robust system configurability needed to be improved in order to allow other schools to integrate this system into their offerings for the career services to their students. Right now, this is really intended for exclusive use with RIT, but it would be nice if other schools could use it in the future. And of course, we think with a new team and some simple brainstorming, there are a ton of features that could be added to this application pretty simply. Is there any questions?
Did you guys have much customizability of the architecture, or was Xamarin PHP like in Django and everything was outlined for us?
We pretty much had our choice of architecture in terms of the back end. We decided to use Spring Boot with MVC. But we could have used anything on that end.
How did you arrive at those, or sponsor arrive at those phases of the interview, like the problem statement and that?
Yeah, when they had that conference that we mentioned where the project idea kind of came up, we were watching a presentation on that idea, and it was kind of the initial thought. That was the initial idea. I'm not exactly sure the person that came up with that, but I think our sponsor really liked that idea and wanted to make it come to fruition, so he wanted that to be what made our app different than other recruiting apps.
Does that just give an option of maybe like if you don't want those, or?
For the options for doing the phases, it's required to do all phases, just so that the recruiter has more opportunity to filter out students and doesn't have to view as many resumes as they might if they just posted it on a random recruiting website. So.
I know it's kind of part of the point of the app was to be different than other recruiting websites. But I was just thinking as I saw it, would it be beneficial to maybe allow the job posting to come first sometimes? Because that's information that I would want to see about a job, like pretty much just up front, rather than going through a process to get to the job posting.
Well, we didn't emphasize, but there's some information that's withheld from both sides. So the recruiter doesn't see the student's name or contact information up until the interview phase. Same with the student doesn't see job description up until the interview phase. This was purposeful, and it was intended like this to prevent bias between both sides. So we didn't want recruiters having their bias or judgments about potential recruits, because of course there's laws that mandate they have to be fair and equal opportunity employers. And then same with the student, we wanted their thought of the job really to be based on those problem statements and the kind of presentation so that they could really understand what the job was going to be about.
So is the application ready for use?
You could use it.
I wouldn't say it's 100% ready for deployment.
There are a lot of raw edges.
But
yeah, the requirement was a prototype. That was the final acceptance criteria from the sponsor, was to create a prototype for him to go and do whatever he wishes to do with it. He's thinking that he wants to submit an application to get another senior project team on this, which, as you can see, there's sufficient amount of work still to be added to the project itself.
A couple questions on matching. I noticed that you were able to put in size of company and location, but you're matching on skills. So do you use the location information and company size as part of matching?
That's meant to be for the sorting and filtering that we couldn't add. So we wanted priority for the matches that students see to go to the matches that have jobs in places that they want or with companies and sizes that they want. In order to keep it fair for both sides, we just based it on those skills. Because otherwise, if a student said, I only want to work in New York, then they might never consider the job in California that they're really the best fit for. But it might be just lower on their priority list.
So to follow come from. Because one of the things here at RIT is we don't want to teach technical skills, we want to teach engineering skills. So where do I put in project management? Where do I put in communications and teamwork? Where do I put in other soft skills and non-technical skills?
The list of skills is just our preloaded database of skills. It's intended, there's a couple different services that our sponsor was considering that we weren't able to integrate. One of them I believe is called ONET, which has relationships of skills and information like that. As far as discretion about putting in soft skills as opposed to technical skills, that's kind of what the division between important and nice to have skills is meant to be, right? A software engineering graduate can learn a new programming language, but you probably want them to understand object-oriented or presentation skills or communication skills. And so it would be the discretion of the employer when they're filling out that job posting to put those as important skills as opposed to nice to have skills.
Any other questions? No? Let's thank the team.